Well, good morning, everyone, or good afternoon, as the case may be. Happy New Year. This is David Castor with EasyPower. Today we're going to be, in our weekly webinar, we're going to be talking a little bit about the smart design capabilities in EasyPower and just kind of talk a little bit about what it can do and how you might be able to apply it and just give you a little better understanding of how it works. We'll go through some basics. I think we may have some time for questions at the end, but I think the questions are going to fall into two basic categories. And the first category is, when are you going to support manufacturer XYZ for motor control centers or switchboards or that kind of thing, or when are you going to support smart design for 345 kV, and so those kind of questions or comments or requests, I would just go ahead and email those to tech support. Or you can also, we have in 9.5, we've added this feedback button here. So you could just click on this, send us a quick note. We'd love to get the feedback on what you'd like to see changed or added, or enhancements to the smart design, or really anything else in the program. If you have specific questions about what we're going to talk about today in my presentation, you can certainly email me directly, and my email address is just david@easypower.com. So feel free to, if we don't get the questions answered in the session, the email helps me keep track of the questions and make sure I get them answered. So feel free to email me if it's something related to what we demonstrate today or talk about. So the smart design feature in EasyPower is an option, so you don't get that automatically when you buy the program. And I'm not really exactly sure about the different suites that are typically sold, but if you do have it, it's going to show up here as this AutoDesign button when you're in database. And we'll go through the options there and show you basically how it works. So what it really is, it's kind of a rule-based system for sizing conductors, sizing circuit breakers, sizing transformers, based on National Electrical Code load calculation. And there's a few other checks that it does, like voltage drop. But that's the basics. So the requirements, if you want to run AutoDesign, basically for your model, you have to have a source. So of some kind, could be a generator, doesn't have to be a utility source. But EasyPower has to have an incoming source of power to figure out what's upstream and what's downstream. And you have to have, it's only going to work on low voltage equipment, 600 volts and below, basically. I believe it will size, if you have a medium voltage to low voltage transformer and it's in our design library, it will size that. So anything above that, medium voltage, like the fusing or the relaying, that's not going to be done as part of smart design. So the file I have open here is the Smart Design 1. Basically, I've renamed it so I don't overwrite the one I have. This is delivered with the program under the sample files, and so you'll be able to pull this up later. And I have another example file we'll look at just to show that it works on more than just this one file. So the other kind of requirement that you need to run AutoDesign really is the load information. That's the basic concept of how it works. It's going to look at your downstream loads, do an NEC load calc on those based on the load types that you define and the NEC rules that it tries to apply. And then it's going to base its sizing on the load. There is an option to size the feeder and the breaker and the feeder based on the bus rating of the downstream equipment. So if I had a 400 amp switchboard or panel board, and if I define that, it's going to size the feeder to that based on the 400 amps rather than the actual load. So you do have that option. We'll take a look at that in a minute. But if you look at this file, we have variety of equipment here. We have a main, this bus 3 is our main switchboard, switchgear, and we have a transformer that's not sized. So we're going to run through the basics of how the SmartDesign works and how you would apply it. Now, there's nothing to stop you from selecting everything in here and hitting SmartDesign and AutoDesign and having it size everything. But kind of to demonstrate what's going on, we'll kind of take some baby steps and work our way up here from the bottom. So it kind of works the same way you would attempt to size something or verify your loads, your sizing anyways, by looking at the downstream loads, collecting all these downstream loads and kind of aggregating those up into the main bus so you can size that and the main breaker and the transformer. So if we go down here, we'll just take this first feeder here as an example. If I, this is a panel board, if you're not familiar with the panel board schedules, it's main lugs only. If I go to the description tab, I have all my loads defined, which is nice. So here's my connected loads, and I also do not have any overcurrent devices sized here, right? So the AutoDesign will work with panel board schedules and MCC schedules if you've defined the loads, basically. So it works in a couple different ways. If I want to just size one row here, one circuit, if I just right click on this, down here I have auto size, protected device, and cable. So if I click on that, I get this message that says the row was successfully sized and there'll be a report created. So if I look across here, you're going to see that I now have a 15 amp circuit breaker, and I have a circuit that's number 12 with a certain size conduit. So it did size that for me based on the load that was already defined of this 560 DA. Okay. It also looks at the load type, if that's defined, the demand load. So the code factors. So if you define something here as a continuous, that's treated as a continuous or non-continuous load, it's going to take that into account as well. So we'll take a look at how these are defined in the library and how you can modify those if you want. So I could go through one at a time and run the auto design for each one of those branches, and it would size the feeders and the breakers. The other option is to just highlight the entire panel schedule and say auto design. Now if I come back and look at my panel schedule, I'm going to see that, oops, there, I have all my, well, it didn't size the feeders. Hang on. Let me look. So every time you run this, you're going to get a report. Okay. So it sized the total load. It says the size panel has no amp rating, and the panel was not sized, so it has to have a transformer value. Okay. So I'm going to go ahead and select the feeder, whoops, the breaker, the feeder, the transformer, and the panel. Whoops. What's going on here? All right. Must be, okay. So now if I run AutoDesign, we'll see what happens. So now it ran, and you see it inserted a transformer size, 112.5 kVA. And for my panel board, I have a total design load here, the code factors load of 211 amps. So it's sized that based on the loads in the panel board. If I come on up, then it's sized this breaker at 150 amps. It's a low voltage power circuit breaker, and this is a feeder is sized on 350 kc mil. Now, one of the things that the program does when you run the AutoDesign is it generates this report. So it's going to list each device and how it sized it. Okay. So it gives you some basis for how it decided what it was doing. All right. And there's the feeder size. And one of the things to note when it's sizing the conductor is it does run a voltage drop calculation, and we'll see how you can set a limit for that. So that's the AutoDesign report. Okay, so that gives me my sizing for this feeder here. Let me just take another look here at my panel. Not sure why it didn't size that. Hang on. All right, so when I told it, I think once it had the transformer rating, it was going to go ahead and size the bus and size all the feeders now in the panel board. So you can see it's gone through and assigned a breaker size based on the loads, and then based on the breaker size, it assigns a feeder size. And we'll see where that data comes from here in a minute. All right, now I can do a similar thing with the rest of these feeders. If I highlight the breaker, the conductor, and the panel, and do AutoDesign, it's going to size all those. Give me a breaker size. Now, if I try to just size the cable by itself, it's not going to size, and that's because I have to size the breaker first. The conductor size here is going to be based on this breaker size. The breaker size is based on the load or the bus rating, depending on which option we pick. So again, I can run through this same process, and I'm going to get my sizing selected here. All right. So if I continue this, I'll get the AutoDesign for the rest of this. Oops. And we'll just finish this off. Okay, so now I've got all my feeders sized. Okay. If I look at my bus 3 here, it does not have any kind of a rating, a continuous amp rating here. So based on the loads that it knows about, it will size this for me. So if I were to select this now, because I've sized everything down here, right? So it has all the load information, it has the breaker sizes. If I select that and the main transformer, then it's going to size. The bus has been sized at 1600 amps. There's my main breaker is 1080, the tap setting, and my transformer is sized at 1000 kVA. So it's gone through and made its decisions based on some mysterious factors we're going to take a look at in a minute and come up with these sizes. So that's kind of the basics of how you use the AutoDesign. The key is to have the loads defined, or you have to have a bus rating for the downstream panel or piece of equipment, whatever it is. So otherwise the program has no way to know how to size things. All right, so that's kind of the basics of how you would use it. Now let's see what's really going on here behind the scenes. The first thing to look at is if I drop this down, I have AutoDesign options. So if I open this up, I have 5 general categories here. And the first one we want to look at is this, something called the Design Library Sheet. All right. So this basically is a table of equipment and feeders and motors that the program uses to do its sizing. This information is stored in the library, and we're going to take a look at that in a little bit. Okay. The other thing to notice under General is this option that says Generate Report Only without changing data. So you have to keep in mind that when I ran this AutoDesign, it's changing data in my file. Okay. So number one, you're going to want to make a backup of the file regardless of whatever else you do. Now, it changed this data in my file, but if I were to exit out of, close this file right now, I have the option of not saving my changes. So if I do that, then it's going to go back to whatever it was before I ran the AutoDesign, right? Because I haven't saved it yet. The other option you have, though, is to just check this. It says Generate Report Only without changing data. And if that happens, you'll only, if you check that, you're only going to get that text report we looked at, and nothing will actually be changed in your design file. So I'm going to keep that in mind, that when I run this, it's actually changing data in my database in my file, my design file. So you have to keep in mind what's going on. The other options are fairly straightforward. When we are looking at MCC sizing, it's going to assume a full voltage non-reversing starter. So it's unlikely you're going to want to default to something else, but we do have those options. Under lines, we have the issue of the tap rule length. You can define whether you want, by default, you want to make these 3-wire or 4-wire. That's just kind of a default setting. And then if you don't have a cable length, you have an option here to have the AutoDesign automatically insert a 99-foot length. Okay. And this option is if you have a facility where it's not a supervised location, you need to size based on the tap or plug rating. If it is a supervised location, you could size the feeders based on the long time pickup. So you do have a choice there. Protective device, this is just choice of whether you want to use, the settings are used based on minimum or maximum. And this is the one where you probably will want to change this, or at least be aware of where it is. As I mentioned, normally the program wants to size your feeders based on the downstream load. So if that's the case, then if you don't have any loads defined, it has no basis for sizing anything. In that case, you could switch this to based on the bus rating. So in that case, if you define, say, this MCC down here with an 800 amp bus, even if your load's only 100 amps, it will still size this feeder based on the 800 amp bus. And if your load is bigger than 800 amps, it'll size it, it'll increase the size and tell you why it did that. So this gives you a way to run the AutoDesign without having all the loads defined. Voltage drops, I mentioned it does a voltage drop calc for each feeder. So basically the criteria is 5% for the steady state, and then it does a motor starting calc for the largest motor downstream. And this is the 20% drop is the threshold you can set for increasing this feeder size for motor starting. So if you want to make that 15% or 10%, change that here. The last option is just if you have a non-defined bus type, this is going to tell it if you want to size that, insert an amp rating in that bus or not to size it. So those are the basic options that are accessible there. Let's take a look. The first one we looked at was this design sheet. So these are what we have available in the library. And you're going to see some manufacturers' names here. And we have the generic, which is the default generic 1 or generic 2. Not exactly sure what the difference is there. So the other option is the bill of material report that I'll talk about in just a second. Well, let's go into the library and we'll take a look. There's really two things in the library that will have a big impact on the auto design. We have the design sheets, and then we also have the demand load factors. I'm going to say OK. I'm going to open up my standard library. And again, I do that by going to Open Library, Standard Library. And so down here at the very bottom, we have Design. And we'll go to US. And these are the same options I saw in the AutoDesign options there in the database. So let's take a look at generic 2 just as an example. There's some notes there you can read. And then we have the different types of equipment where we have data. So if we look at motors, it's based on voltage class. So we have standard voltage, nameplate voltages, 115, 200, 208, 230, 460, and 575. So if I go to 460, basically we have the standard NEMA horsepower ratings up to 500 horsepower. There's an NEC amps that come out of the Article 430, and then full load amps, 125% of the full load amps. There's some price values here that I wouldn't put a lot of faith in, but it gives you an opportunity to update those if you have numbers you like better. And these are the protected devices that are going to be used. And the feeder size. So we have insulation type. It's going to use THHN based on what we have here. You can change that if you want to use THWN or use XHHW for the bigger sizes. This can be customized for whatever you want to use as your design standard. Okay. So basically, when EasyPower finds a 100 horsepower motor, it's going to go look in this table to figure out how to size that feeder. Conduit size, and it's just going to plug in that value based on the horsepower rating. So if you have a non-standard horsepower, the AutoDesign is going to fail. It's not going to work. It's going to have to find a listing in this table here. So you could either add to this or those you might have to size manually at this point. Okay, so those are the motors. We have a similar table for the feeders. So if EasyPower calculates that it needs a 175 amp circuit breaker for that downstream load, this is the feeder it's going to put in. So one per phase, single conductor, so 3 single conductors, THHN, 2-aught, 90 degrees C. Ground is number 6. It's going to default to steel conduit, 1 conduit, 1.5 inch with this ampacity, and 175 degree or 75 degrees C, 175 amps. So basically it's going to go up the table till it finds the right size and then insert this size into the AutoDesign. So it's actually fairly straightforward. If you have a 4-wire circuit, then there's a different table. Okay. So the only thing it's going to affect is the neutral and the conduit size. All right, so let's take a look at the protective equipment. So it's broken down by type. You notice when we ran that AutoDesign previously on that main bus, it inserted low voltage power circuit breakers, the class. And that's because we had defined that bus as switchgear. We'll go back and take a look at it in a moment. If we define that as switchboard, then it's going to use molded case circuit breakers. So these are the sizes that it has available in the library. So it's the smallest size it has is 800 amps for low voltage power circuit breaker. These are the other options. So again, according to what type of equipment you define, this is what it's going to use for those particular feeder breakers. So if I have a 400 amp circuit, it's going to use a particular size MCP here for this MCC feeder. If it's a feeder, then it's going to use a generic, because this is a generic category, that breakers are all the generic type that's available in EasyPower for molded case breakers. Okay. So this is where it looks to determine, once it figures out what the load is, what type of breaker to put in. So it's going to go to the next, basically the next larger size, if the size doesn't come out exactly right. Now, if we pick a particular manufacturer, then the protective equipment is going to be based on a particular design or style of that particular manufacturer. Okay, so for the GE, we have Wave Pro. For low voltage power circuit breakers, we have Spectra for molded case breakers and so forth. So you could create your own design sheet by copying one of these, making modifications, and if you have a different manufacturer, you could build that in. This is fairly flexible. It's fairly easy to modify, so you could create your own customized design sheet. But this is where the program is looking to determine what type and size of breaker to put in once it figures out the loads. For bus equipment, then these are the different bus ratings that it has. Okay, so it has a 600, 800, 1200. That's as big as it goes in the MCCs. Okay, so these are the standard bus ratings. So it's going to go to the size that's above whatever it calculates your load is, basically. And then these are the transformers that it knows about. Now it's based on, we have different tables for different voltages. So if you have, let's say, 480 to 208, it's the most common. These are the sizes that it has. So it's going to go 30, 45, 75, 112 and a half, 150, etc. So it's going to pick the size based on what's available in this table. Okay, so that's where the design sheets are located in the library. The other table you may want to modify is the demand load. This is where you can list the different types of loads and so basically if it's a continuous load, you're going to use 1.25 if you're doing it per the NEC. And if you have receptacle, like non-dwelling receptacles, you can have different demand factors, different levels of VA loading. So give you some flexibility here on how the loads get defined. We always have the motor category, so it's going to take 1.25 times the largest motor and 100% of all the other motors. And that can be adjusted here, but this would be per the NEC right now. Okay, so that table can be modified. You could add a different table, customized table, and reference that. Okay, so let's jump back over to our little example here. So we see that these are all low voltage power circuit breakers. And why did it pick that? Because if I go into my data for this bus, it's defined as type switchgear. So in addition to, we know that the arc flash calculation uses this type to determine the gap, or whether it's in box or in air. But the AutoDesign also uses this value here. Okay. So if I change this to switchboard, now if I rerun this, it's going to change these breakers. Okay, so these were low voltage power circuit breakers, but now they're molded case breakers. Okay, and that was changed because, whoops, this feels like Monday today. That was changed because I changed that from switchgear to switchboard. So this type has a big impact on the AutoDesign and what it's going to try to put in there for you. So whether it's an MCC bus or a panel board bus, you need to define the correct type to get the breakers you wanted. All right. Bill of material. So you'll notice there was a box under the options for bill of material. Take a look at that again. Go back to options. Generate bill of material report. I haven't looked at that yet. So one of the things about AutoDesign is I can, even after I've run it, I can rerun it to generate the report again once I have everything the way I want it. I can select everything, rerun AutoDesign. It's going to go through the same process again because nothing should change because I've already run it. And now if I go to my bill of material report, this is what that's going to look like. So it's broken down by type of equipment. So this is based on the things that I ran just the previous AutoDesign on. So if I selected the whole one line, then I get a listing of everything. So this again is going to be a file that you can export to Excel or Word like you would a short circuit report or power flow report. So in the library, some of this data, some of these equipments have cost value associated with in the library. So that gets plugged in here. I would, like I say, I would not put a lot of, I wouldn't bet a week's pay on the prices being exactly right. Electrical equipment is very difficult to know who's paying what because of the different multipliers and discounts, but this at least gives you a starting point, and you could modify the library, you could adjust these costs as you need to, but it does give you a breakdown of the total quantities for different size conductors. Okay. So this and the conduits, I believe, yeah. So here's the different conduits, total lengths, cost per foot. So obviously it's not going to satisfy everyone's needs in terms of bill of materials, but it could be a starting point for you, and it could provide some value. One of the things I wanted to touch on as well, we mentioned that the program does a voltage drop calc, and we can take a look at that here real quick. So for this particular MCC here, the feeder is, these are all 99 feet because it defaulted to that. And it says it's 2 600 kc mil per phase. Now if I were to go in here and change this from 99 feet to, let's say, 900 feet. And if I were to rerun this AutoDesign, and it didn't change yet. So let me look at the report. So the voltage drop estimate was 3.7%, so still under my 5. If I go back and change it to, say, 3,000 feet, it's a long 480 volt circuit. Now if I rerun the AutoDesign, now I have 5 600 kc mil per phase. And if I look at my report, I'm going to say it was 2 600 kc mil per phase, but the voltage drop was too high, so it increased the conductors to 5 600 kc mil per phase, and that comes out to 5%. It was 12.5%. So, you know, normally it's not a big issue, but it's a good way to get a check on your voltage drop for all your feeders, and it will automatically upsize those until the voltage drop is within that criteria that we set of 5%. Okay, just to prove that that is actually going on. So the equipment inside the MCC does get sized when you size everything. So If I right-click on the MCC, do AutoDesign, if I size everything, then if I look inside, it's going to, based on the motor horsepower, it's going to insert the appropriate MCP size and the feeder size that goes with that particular size of motor. One thing that was kind of a byproduct of the AutoDesign is the load summary. If I go to my MCC, I'm going to run a calculator here, but this has been added to include the downstream loads for the MCC. So this is the actual load that's directly connected to the MCC. But this value includes the downstream load. And if I look at the code factors line here, this 217 kVA and the 266 full load amps does factor in the 125% of the largest motor and 100% of all the other motors. So this is a NEC type sizing calculation for that MCC, including all the downstream loads. You'll want to make sure you hit that calculate button to make sure it's, if you've changed anything downstream. But it does aggregate all these loads downstream and gives you a summary here. This is per the NEC, 125% of continuous loads. Okay, so that's kind of the basics. So remember, we're limited to low voltage equipment. It's not going to size this fuse for me. It will size a medium to low voltage transformer based on what's in those design sheets, right? So it's going to pick the one that's large enough to do the job. So I think, you know, if you're like an old guy like me, even doing design for a long time, at first it didn't seem like this was really providing a lot of value, but the more I've used it, the more I see it's really valuable as a preliminary sizing and also as a final design check. So I think it has a lot of value in just kind of helping keep track of the loads and also to maybe look for things like voltage drop, which might get missed in certain situations. So we mentioned that when I run AutoDesign, it's actually changing the data in my file, unless I say produce report only. But what if I had a situation where I did not want the program to change something in the AutoDesign? So we have the ability to lock the AutoDesign, and we can do that for any piece of equipment. So let's say if this was an existing transformer, so I don't want the program to say I need to change it from 1,000 kVA to a 500 or to a 2,000 because it's already there and I can't change it. So if I go to the transformer data, somewhere in the data is going to be this box that says lock auto sizing. So if I check this box, then if I were to rerun this, then EasyPower would not change the size. I might get a report giving me some comments about the size, but it's not going to change the size of my database. Okay, so if I look, say, at any one of the breakers, I have a similar box here, lock auto sizing. All right, check that. Now, if I have common situation, would be where I'm adding on to an existing facility. And there, what you might want to do is lock all the existing equipment so it would not auto size that if you accidentally pick that. So we do give you the ability to do this as a group. So as an example, if I were to just highlight this whole substation here, I could come up under AutoDesign and say lock. And once I do that, everything I open up here should be locked. Okay. Notice that for the MCCs, it's locked and unlocked on a per MCC basis. I don't believe there's any way to do that for an individual feeder. Okay. And if I want to unlock it, it's just the reverse of that process. And there's an unlock option down here as well. Okay. So one thing to keep in mind is that we've run this, it's made these changes in my database, but I still have the option of saving this or not saving it. So if I were to close this file now and if I do not save my changes, then the AutoDesign, things that the AutoDesign changed would be discarded, and you wouldn't have to worry about that. I thought we would also take a look at another file that I created, just a little simpler one to kind of give you an idea what's going on and maybe some things you could do with it that you might not think about. I think I have this. There we go. So let me open this up. All right, so there's my email address if you guys have any questions about, if you think I pulled a fast one somewhere along the way. I have a simple system here. We're just going to play around a little bit with the AutoDesign and see how it works, and some of the other, just to kind of go through it again on a different file, highlight some other capabilities maybe. Again, we have to have a source. We have to have either our loads defined or we have to have a bus rating, okay? So here I have a main piece of switchgear. Now I've defined this as switchgear. So by selecting switchgear, it means it's going, when I run AutoDesign, it's going to use low voltage power circuit breakers. If I wanted molded case breakers, I would change this to switchboard, right? But for now, I'll leave it at switchgear. Now we got MCC1, and I have a subfed MCC1A just to show you that that can be accommodated in the AutoDesign and the load calcs. Okay. So if I go down to this MCC, I've got it defined as a 600 amp horizontal bus, main lugs only, and I have these loads, 3 motors, and they're 50 horsepower, 200 horsepower, and 25 horsepower. So I have a big motor hiding down here. So now, when you're building your MCCs, you have the option of running AutoDesign will work inside the schedules. So if I select this motor, I've got the motor horsepower defined, but I don't have the feeder or the breaker defined, right? So if I right-click on this row, I have auto size protected device and cable, and it says was successfully sized. So now if I look, I'm going to have, it's assuming a full voltage non-reversing starter. But if it's starting across the line, then it's got a 150 amp frame MCP with a 100 amp trip, and it's got number 3 copper conductors defaulted to 99 feet. It's got an 1.5 inch conduit, okay, and the ground wire is number 8. So that row was sized based on basically just the motor horsepower, and I can do the same thing per row. If I want to size everything, then I would come back. If I right-click on the MCC and the one line, I have this AutoDesign option here, and I have 5 choices: size everything, size bus, main, and feeders, bus and main, bus only, or main only. So I'm going to say size everything because I'm lazy. I tell it that. Then if I come back and look here, and it's reduced this from 800 amps to 400 amps because it's saying that's all you need, right? Because it wasn't locked, so it did change that size. And if I go to my description tab, then it's got all those feeders and breakers are sized, okay, per the motor horsepower that I defined. Now if we go look at the summary, then this is basically my NEC load calculation here. 399 amps. Code factors would be with 125% of the largest motor and 100% of all the other motors. All right. this. Okay, so now I have sized this, it has the loads, and then I can size this feeder now. If I come in here, I have the similar situation with the MCC1, except in this case I have a subfed MCC, right? So when I have a subfed panel or MCC, I need to define it in my schedule like this, change my load type to sub MCC, tell it which feeder it is, and then which MCC it is. All right, so that's part of building the MCC panel or the MCC schedule. So here's all my motor data that I have here. So you can see my motors here are 150 horsepower, 100 horsepower, 125, 75, and 60. So again, these are not sized. So if I go back, it's giving me a warning here saying I have a bus rating of 800 amps, but the load is 1032. So I'm going to fix that hopefully when I run the AutoDesign. So I'm going to say okay. Now if I come back here and say size everything, it's going to run the AutoDesign. I need to size this feeder. So it upsized that from 350 to 500 because I have a 400 amp bus down here. So now if I look at my description, I've got all my MCPs defined and all my feeders for all my motors. If I go to my load summary, this code factor's load of 1032 amps is going to include 125% of the largest motor fed from this, but that motor is actually the 200 amp motor that's down here, right? So it will go through and pick up, when I have a subfed MCC, if the largest motor is down here, it will use that largest motor because it's sizing this MCC's NEC load, basically. All right. So then I can come back. Now, if I try to size this conductor, AutoDesign, it's not going to size. Even though I've got this all sized, it will not size the conductor until I have a size for the breaker. So the breaker gets sized first and then the feeder. I can do them both together. And that will work. Okay, so I defined this as switchgear, so now I get a low voltage power circuit breaker, 1200 amps, 4 350s per phase, and it has increased my horizontal bus rating from 800 to 1200 based on the AutoDesign calculations that it did. Okay. And then I can size this one it's going to base it on the load that it's found down here, okay? There is no upstream breaker here, so it went ahead and sized this. All right, so that's kind of the basic idea. If I didn't have any loads here, and I defined this as 800 amps or 1200 amps, it would size that breaker and feeder based on this bus rating here. So in the old days, we used to say that this is strictly informational and that wasn't used by the program for anything, but that is no longer the case if you're running AutoDesign. It will use this horizontal bus rating, or for the panel board schedule, the bus rating, as part of the sizing, depending on the options that you pick. So that data is used by the program. All right. So one other way you could use this is if I have a feeder size, a breaker size defined, it will size the feeder for me, even if there's no loads or anything else down here. So just to show you how that would work, I'm going to put a feeder in here. Just going down to a generic bus, and I'm going to put a breaker. So if this breaker happens to be I'll just make it generic 400 amp breaker. I'll have to size the trip. Once I have this size defined, if I just size this conductor by itself, it will size because it's just going to size it based on this 400 amp breaker rating. So it sizes it to one 500 kc mil, which is good for 380 amps at 75 degrees C. So when you look at any of the conductors, we give you the 430 amps would be at the 90 degrees C ampacity of the conductor. But EasyPower knows that I'm limited to the 75 degrees C ampacity in general. So it's going to use the 380. So you can use the next larger size because it's within that range, so I can use a 400 amp breaker to protect the 380 amp cable. So if I have the breaker size defined, it will size the cable based on this breaker size. I do not have to have any additional information. Now, it's not checking voltage drop or anything, obviously, because there's no load down here, and that will show up in the design report. So it says unable to verify the voltage drop because the downstream load amps equal 0. So basically it's sizing it strictly on the breaker size, right? Okay, so that's kind of the basics. Just a quick review. Remember the main things are which design sheet you pick and how you might customize that in your library. So if you're not understanding why it's going to a larger size than you think it needs, then you might want to go look and see in the design sheet. What it's going to do is keep going to the size until it gets to one that's big enough. So if there's a size that's not in the library, it can't use it. So it only can pick from what's available in the library here that you picked, the design sheet. Okay. The other key thing to remember is that the program is going to change your data when you run this in your model. So keep a backup. You could run this in a scenario. You also have the option of just generating the report without changing any data by checking this box. And in the emergency mode, you can just close the file without saving any of the changes since you started running AutoDesign, and those should be discarded unless you have autosave turned on. So that's something to keep in mind. If in your options you selected the autosave, then you may want to be a little bit careful about combining that with the AutoDesign. So that's just kind of a quick overview of the AutoDesign. Obviously, right now it's very much keyed to the National Electrical Code in the U.S. And we'll probably be looking at expanding that capability in the future to maybe other countries. Canada, obviously, it would be an obvious choice. But at this point, it's limited. It's really geared to the National Electrical Code in the way that loads and breakers are sized for that. And I suspect there'll be more enhancements and changes made to this as we go along. So hopefully you get an idea of how it works and the capabilities, and you might want to play around with it a little bit. You don't have to run AutoDesign on the entire model, right? You've seen we can just pick and choose what we want to run it on, and until you get comfortable with it, that's probably a good way to go. So we have a few minutes left. I'll see if we do have any questions. I can try to take them. Again, if you have questions, feel free to email me at david@easypower.com. And if it's an issue of wanting to add additional manufacturers, additional capabilities to the AutoDesign, I would recommend you just hit the feedback button here or email tech support and make your wishes known. We'd certainly like to hear from you about your feelings about the AutoDesign or really anything else related to EasyPower. So with that, let me see. I think I do have maybe a question or two here. So there's a question about the short circuit and coordination. So for short circuit, it does run the short circuit calcs, and it will tell you if your interrupting rating is not high enough, and it will try to select a device. The design sheets only have a fairly limited selection, obviously, but it does check the interrupting ratings, and you can obviously run the equipment duty check as well, which I would recommend. As far as coordination, that's not really part of AutoDesign. We have a separate capability module called SmartPDC Auto Coordination, which is similar to AutoDesign, except it actually tries to apply settings, and it will actually check your overcurrent coordination. So that's kind of a separate function from the AutoDesign, although it works in a similar way. Would the software recommend spares? No, not really. You would have to do that yourself at this point. Any plans to add Allen Bradley MCCs? I don't know. That's not really something that I'm privy to about exactly what the next features and capabilities are going to be, but I would certainly say you could make that request. That seems very reasonable. So it's just a question of, and it wouldn't be that hard to create your own library design sheet that you can copy one of the existing ones and just change the manufacturers. I have a question about forcing a change to 2-3 conductors in parallel and still have a calculated voltage through. So basically the way it works is it's going to go back and look at that design sheet in the library. So if we take a look at that again, if you look at our design sheet, all it's going to do is go down this list till it finds a breaker that's big enough, and it's going to use whatever conductor is in this table. So there's no way to really, if I have a 500 kc mill here, single per phase, I want to change that to 2 350s. There's really no way to do that inside of AutoDesign except by changing the library. I could change it here, and then it would always use that size. But you would have to go back in. I mean, it's always going to be a starting point for you, and there's really, AutoDesign's not going to replace, the engineer or the designer going back and making the final adjustments and checking everything. So we don't have a way to force it to change from this. It's going to use basically whatever's in this table. If you change the conductors and lock it, it will stay where it is. It will run the voltage drop calc, and you'll get a report back showing if the voltage drop's too low, but it won't change it. And there's no way for you to force it to change from what's in this table, basically. Okay. Let's see. Any more questions? Regarding spares, how to resize the buses. Again, the program is going to give you a minimum size that it thinks is required for that bus. You can increase it manually and then lock the bus. If you look at the options, there is an option. So normally you would use the code factor amps, which is going to be the NEC design. We have other load calculations here that we have connected amps, demand amps, code factor amps, design amps. So if you go back and look at the load definitions, there is a design factor that you can apply. So if you wanted to allow for 20% excess capacity, you could just use a 120% design factor on top of the calculated load, and then it would allow for some additional capacity in the bus and in the feeders. So that would be one option, but that's kind of an all or nothing right there. So you would want to be a little bit careful about using that. But you would have that capability. You can play around with the different factors that get applied to the load count if you want to allow for some additional load in the future to oversize things slightly. Let's see. Okay, so I think that covers most of the written questions. If you have additional questions, feel free to email me, and if there's things you want to see added, like I say, just email tech support and we'll be glad to do that. So I want to thank everybody for showing up the day after New Year's, and hopefully you got something out of it. So there will be another one next Thursday that Satish is doing. I don't remember the topic offhand, but I'm sure there'll be an email on that. So thanks for coming around, everybody, and we'll be talking to you soon. Thanks. Bye.